So today we're going to look at logarithmic rules. We'll look at 5 particular rules: the identity rule, the zero power rule, the product rule, the quotient rule, and the power rule. We'll get into each of those in detail. But first, what's the definition of a logarithm? The definition of a logarithm is if b to the a, if some number to some power equals x, if we raise this number to this power to get x, then the log of that base number, that b, the log b of x equals a. You can think of the log of a number in a particular base as the power to which you need to raise this number to get to this. And that's right here, right? So if b to the power of a equals x, then the log base b of x equals a. So for example, let's take b equals 2, a equals 3. That's 2 to the 3. And what does that equal? That's right, it equals 8. That means that the log base 2 of, what's x here? X is this 8. The log base 2 of 8 equals 3. 3 is the power to which you need to raise 2 to get to 8, because we're talking about logs in a base 2 here. Now, similarly, you may have a log base e of a particular number. Let's say a log base e of 10. That's also known as the natural log of 10. So the log base e, and e is approximately 2.71828. It's a very useful number for doing these sorts of things. And the more math you do, particularly when you start doing calculus, you'll recognize the power of this this constant e. So that's the the log e of 10 is also called the natural log of 10. So we don't bother writing a base e. But if you see ln for a natural log, understand that there is an implicit e here. That is, the natural log of 10 is the number to which you need to raise e to get to 10. It would be so if the natural log of 10 equals y, it also implies, going back in this rule, that e to the y equals 10. So now that we have that definition, we're going to leave the definition at the top of the page just so you have that available to you. Let's look at some, first, 2 basic rules. First, an identity rule. Now, we know that any number raised to the first power is that same number. E to the power of 1 equals e. That's why I say identity. If you raise something to the power of 1, you get the same number. And the equivalent here is that the log base 2 of 2 is 1. That is, you raise 2 to the first power to get to 2. There's kind of, there's a little hint here when you're looking at a log function and it's a little puzzling to you. There is, the hint is that the base here raised to this power equals this, just so you recognize. And in this case, we have log base e, which is also called the ln, so the log base e of e, so the ln of e is also equal to 1. And that's because e to the power of 1 equals e. So that's the identity. Log of any base to that same number is equal to 1. Now similarly, 2 to the power of 0 it's 1. That's by definition. E to the power of 0 equals 1. So the 0 power, if you have the, so the 0 power equivalent here is that the log base 2 of 1 equals 0. That is, we raise 2 to the power of 0 to get to 1. Similarly, the log base e of e, also called the ln of e, equals 0. I'm sorry. The log base e of 1, also known as the natural log of 1, is 0. Okay, now let's go on to some more complex ones. And first, we'll look at the product rule. So you may recall that if you have some base to a power, multiply that by that same number to a power, that's equal to that base to a power. So for example, 2 to the second times 2 to the third equals 2 to the fifth. And you add these two exponents to get to the sum. So, and let's just check that. 4 times, and what's 2 to the third? That's right, it's 8. 4 times 8 equals 32, which is 2 to the fifth. So this is a rule of exponents. Let's look at the equivalent rule for in logs. So let's look at the log base 2 of 4 times 8. In this case, x is going to be 4, y is going to be 8. That's defined as, and this comes, this may seem a bit odd, but it's actually log base 2 of 4 plus the log base 2 of 8. If you have a product as your argument for a log, you separate the elements of that product into individual additions. And let's just look to see, so what's log base 2 of 4? What number do you need to raise 2 to get to 4? That's right, 2. What number would you raise 2 to get to 8? 3. And then this is the log of 32. What number would you raise 2 to get to 32? It's 5. That equals 2 plus 3. So if you have a product in your log argument, you can separate that product into two added logs. Similarly, if you have a quotient in your log function, and this is because b to the x over b to the y equals b to the x minus y. Let's confirm that. 2 to the power of 3 over 2 to the power of 2 equals 2 to the power of 3 minus 2. And in this case, what we have is, again, 8 over 4 equals 2 to the 1. That's right, 2 equals 2. So let's see how that works in logs. So the log of some base, the log base b of x over y is equal to log base b of x minus log base b of y. So let's look at an example here. Log base b of 16 over 2 is equal to log base, this is log base 2, log base 2 of 16 minus log base 2 of 2. So here we have log base 2 of 8, log base 2 of 16 minus log base 2 of 2. So the log base 2 of 8 is equal to the log base 2 of 16 minus the log base 2 of a. It's a little odd but just think of the fact that you are making a division, a subtraction, just as in this case you made a multiplication and addition. A multiplication in numbers is an addition in their logs. A quotient, a division, in the argument of a log is the difference between those logs. Let's just confirm that this is right. The log base 2 of 8 is, what number do you raise 2 to get to 8? That's right, 3. What number do you raise 2 to get to 16? 4. What number do you raise 2 to get to 2? Well, from our identity, it's here. It's 1. You raise 2 to the power of 1 to get 2. And what we have is 3 equals 4 minus 1, which is 3 equals 3. So, and that's true also if, log e of some number over another number, which is also called the ln of this quotient, is equal to the ln of 10 minus the ln of 5. In each case here, this number here is the number you would have to raise e to get to 10, minus the number you would have to raise e to get to 5. That's the quotient rule. Now, let's look at what happens when we have powers, when we have some number to another power. Let's look at the case where x is equal to 4 and y is equal to 2. And we're going to do log base 2 again. Log base 2 of 4 to the 4 squared, 4 to the power of 2, equals, and this may not look right, but it is so, it equals 2 times log 2 of 4. That is the log of some number, the log base b of some number raised to a power equals that power times the log of the number that's raised. Now, how do we know that's true? Well, for example, let's look at it this way. You could also, in this case, write 4 squared as 4 times 4. And how would we solve that? Well, let's go back to our product rule. On our product rule, the log base b of x times y equals log b of x plus the log b of y. So let's look at it. So let's solve this here. We've got 2 4s, so what we have is we have equals log 2 of 4 plus log 2 of 4. And of course, if we have 2 of the same numbers, we can just add those together. So now we have log 2 base 4. It's also important to remember that this thing here, this log, this is one number. this isn't a couple of numbers. It is 2 times a particular number, which is the number you need to raise 2 to get to 4. So here we have log 2 of 16. And what number do you need to raise 2 to get to 16? 2 to the 4th equals 16. So log 2 of 4, log 2 of 16 equals 4. And then here, what do we, well, 2 squared equals 4. So the log base 2 of 4 equals 2. We have 4 equals 4, so that checks. And that the same thing is true if we're doing the ln of 4 squared. It would be 2 times the ln of 4. The ln of 365,473 squared equals 2 times the ln of 365,473. And that's true, if you had, you could extend this out to any number of y. So whatever number of y, you would be multiplying that number of your x's. So 4 squared means 4 to the 2 means 4 times 4. 4 to the 3 would be 4 times 4 times 4. 4 to the 4th would be 4 times 4 times 4. And you would just extend that out. It would be a number of adding the same log base b of x. So that's the power rule. So what we've done is we've looked through 5 rules for logarithms. The logarithm, the identity rule. How do we get how do we raise some base to itself? That's 1. If we want to raise that base to 1, it's 0. If we have the log of a product, the log of the product equals the sum of the logs of the individual items. The log of a quotient equals the difference, the log of the numerator minus the log of the denominator. And log base b, a some number raised to a power, is that same number, the power number, times the log of the number that's being raised to the power. I hope that's been helpful. If you found this useful, please give me a thumbs up and subscribe if you want to find more. The next problem will be, the next time we will be doing log problems using these same rules.